Welcome to a tutorial for Lewis structure drawing. I'm going to do about 3 different molecules, and we're going to use them to talk about some of the important terms associated with the Lewis structures. The first one we're going to do is nitrate. So first of all, we have to figure out how many electrons are coming in. We have 5 coming from the nitrogen, plus 3 times 6. And then since it's a negative ion, we have 1 more to give us a total of 24 electrons. So if I start with my normal nitrogen, and then I'm going to have my oxygens with their 6. One of the first things I can do is add in an electron for the one that we are missing. So I'm going to put my additional electron on this oxygen. It doesn't matter which one I put it on, but now I know I have the correct numbers of electrons. Next thing I'm going to do is single bond everything. So I'm going to erase the 2 dots there, make a bond. Get rid of my 2 dots here, make a bond. And get rid of my 2 dots here, make a bond. Now the biggest issue I have right now is that I have 2 single electrons, which is not correct. I can never have any unpaired electrons. So I'm going to move one of them over by the other to make a pair. So now I'm going to check my octet rule. So I have 2, 4, 6, 8 for the nitrogen. If I look at the oxygen here, I have 2, 4, 6, 8 for that oxygen. I have 2, 4, 6 for that oxygen, so that's one we have to deal with. And I have 2, 4, 6, 8 for that oxygen. Okay, so let's clear our space a little bit here. What I can do is anytime that I have a lone pair, I can move it to a shared pair. So the oxygen that is not stable right now is only attached to the nitrogen, so I have to look to the nitrogen to get electrons. This lone pair of electrons could be moved into a shared pair, which is exactly what I'm going to do. So I'm going to take them off the nitrogen and create a second bond with the oxygen. So now nitrogen is stable. I have 2, 4, 6, 8 around the nitrogen, then 2, 4, 6, 8 around this oxygen. The other ones are still stable. The last thing I would have to do with this Lewis structure, because it is an ion, is I represent that with brackets and the charge. And there we have our final nitrate. One last thing I'd like to point out is because of my double bond here and the fact that I could have placed it on either of the other 2 oxygens, we would say that this particular structure has resonance. It means that there are multiple ways I could draw the Lewis structure that still fit the criteria and are correct. So nitrate is a molecule with resonance. The next one we're going to take a look at is SF4. Okay, so I would have 6 electrons coming from the sulfur, plus 28 coming from the fluorines to give us a total of 34 electrons. So in this case, it's a little bit easier to just start by bonding the things that are bonded to the sulfur. And then I'm going to fill my fluorines. Remember, I'll need 6 dots or 3 lone pairs because of the bond that's already happening with sulfur. And then I'm going to check my total number of electrons to see how many that puts me with at this point. So if we take a look, for every fluorine right now that's connected by a bond, that equals 8. So I have 8 times 4 fluorines. That means I have 32 electrons. I am missing 2 that are needed to get to my 34. Sulfur is one of those elements that is greater than the 3rd row, or in the 3rd row, which means it can hold extra pairs of electrons if needed. It has an expanded octet. So I can place those final 2 electrons as a pair on the central sulfur atom. So in this case, When drawn this way, the sulfur actually has 10 valence electrons, but because of its size and the fact that it has a third energy level, it is able to fit that many electrons and still be stable. So when you have electrons that are missing in the way that it's drawn normally, just check and see if your central atom is in the third row or lower on the periodic table. Last one we're going to do is BF3. This is an additional exception to the normal octet rule. So I'm going to have 3 valence electrons from boron plus 3 times 7 for the fluorine to give us a total of 24 electrons. If I start by bonding my 3 fluorines to boron and then drawing in my electrons to make the fluorine stable, when I take a look here and account for each fluorine, each one with a bond equals 8 electrons again. 8 times 3 fluorines equals 24 electrons. That is what I'm supposed to have. Normally, we'd notice the boron only has 6 valence electrons because of the 3 bonds. But because of its small size, boron can be stable with less than an octet. So this would be an okay and following the criteria drawing for this particular compound. Biggest thing, your first criteria is making sure you have the right total number of valence electrons, then fulfilling the octet rule. If you cannot fulfill the octet rule, double check to see if it's one of the ones that is an exception to the rule.